Slot. Thank you. I should be clear here. What I'm going to talk about is public cloud platforms in enterprises and how I have seen enterprises adopt public cloud platforms. As a concrete example, I'm going to use Microsoft Azure. Realize, however, I don't work for Microsoft. And so not a single thing I say here today represents anything other than my perspective. I do not speak for Microsoft. OK? Having said that, though, they told me the following. They told me that after this session, not now, but after this session, you can leave the room and be given an orange ticket. And when you get the orange ticket, you can then, if you choose to, go to their booth at 7 p.m. tonight for a chance to win, yes, an Xbox. So if you want to do that, feel free. Go ahead. So let me ask this. Who in the room works in enterprise IT? Business, government, somewhere in IT. Oh, good. Probably half the room, something like that. Great. I know these events often draw a pretty heavily vendor-oriented audience. My talk is for you. The truth is that I've done this as a session for small groups of enterprise IT leaders, CIOs, heads of infrastructure, head of app dev, chief architect, around the world. I've done this talk many, many times for groups of IT leaders. And my goal is to help them understand in a concrete way what public cloud platforms can bring to their organization. And again, the concrete example is Windows Azure. So let's start. What is Windows Azure? You know. I'm sorry. It's Microsoft Azure. I can't get used to this. They changed the name. It's no longer Windows Azure. It's now Microsoft Azure. You know why they changed the name? I'll tell you later. It's interesting why they changed the name. You know what it is. It's a public cloud platform, provides computing and data centers around the world. Wonderful. Now, I don't care where I am, what country, what city, what vertical market, every single conversation, every single time you talk to IT leaders, and they realize that we're talking about a technology that puts their data in data centers in other countries, possibly, in other states, outside their world. I don't care what people think. I know there's a perspective in some quarters that these issues about trust and security are old hat, they're over. No way. No way. In my experience, people who run enterprise IT, especially the guys who do infrastructure, are fundamentally conservative. And so every country, every city, every group, the first question I get once we realize this is the following. It is, come on. Can a public cloud platform really keep my data and my apps safe? In fact, that is the polite version of the question. Far more often, I get something like, David, are you out of your mind? Do you really think I'm going to put my critical data in data centers owned by Microsoft or Amazon or Google in other countries, other states? Are you nuts? People say, what about security? Here's the thing. The way to understand this issue is to realize first and foremost that it is not a question of security. It's a question of trust. You have to learn to trust your cloud provider. Because here's the thing. Anybody in this room run a data center? Have responsibility for a data center? Anybody? Some of you do, right. You know that you lay awake at night, some nights, pondering whether the firewall settings are correct on your routers, because it's your responsibility. With public cloud technologies, maybe you can take a tour. Microsoft, for example, will take you on tours of Azure data centers. You can walk through. They'll say, look, over there, servers. Look, over there, more servers. That's about it. They will not let you check the firewall settings. You have to trust them. This is about trust. And so, as I walk through the scenarios that I see enterprises adopt with public cloud platforms, there is an order in which they adopt these scenarios, typically. And that order is reflective of this concern. Almost everyone starts small, builds trust, moves from there. Almost everyone. It's the rational thing to do. Which is not to say that IT leaders are actually rational. I find that people are deeply irrational on this issue. For example, I'll talk to a CIO who will say, David, I would never put my data in the cloud. And he'll then send me critical documents via Dropbox, which runs on Amazon, or OneDrive, which is on Microsoft data centers. Or my favorite example, ask yourself this. What is the world's most dangerous technology? What is the world's scariest technology? Is it nuclear weapons? Is it maybe some computer virus that's going to eat all our systems? No. No. The world's most dangerous technology, the world's scariest technology, is Windows Update. You laugh. But think about this. Every Patch Tuesday, Microsoft puts directly into your operating system whatever code it feels like. And what do? You say, install. Maybe you test to make sure things don't break. But how do you know that the next update, or the last one, doesn't contain code that steals all your private data? You don't. Suppose that this evening it was announced the government of North Korea was buying all the assets of the Microsoft Corporation. Unlikely, I know, but suppose. Would you turn off Windows Update? I sure hope so. I sure would. My point is, the level of trust we already have in vendors, such as Microsoft, as evinced by our use of Windows Update, far exceeds what we're asked to do with cloud platforms. It's far deeper to let someone put code in your OS every Patch Tuesday. And yet we do it. In fact, we do it so easily that you laughed when I proposed that as a dangerous technology. 5 years from now, 10 at the most, people will laugh at the notion that public cloud platforms are dangerous. So great. Once enterprises start to deal with the trust issue, question number 2 is always this. It's always, can I really still meet my regulatory requirements in the cloud? The answer here, in my experience, is just complicated. You've got to work out what applies to you, and you've got to follow the rules. And that's hard. It's hard because the rules are different across different vertical markets, financial services, retailing, healthcare, government, and they differ across countries. The result is a matrix of rules and regulations which, frankly, nobody in the whole world understands. On my more depressing days, I think no one really understands even any single cell of this matrix. Because these laws, by and large, were defined prior to the advent of cloud computing. And so you're just not seeing much rationality here. At the same time, here's what I see. I see 2 things. Thing number 1, people ignore this stuff. Now, IT doesn't ignore this stuff, the business does. When you put things on Dropbox or OneDrive, do you worry about regulatory concerns? You don't even think about it, probably. But you may well break the law if you do that. People just don't sweat this, which I would not recommend, just describing what happens. Second, when IT organizations bite the bullet, get lawyers involved, and work out what they really can do within the constraints of that matrix, my experience is that more often than not, they find they can do more than they thought they could. I was in Paris not too long ago. I talked to the CIO of a big French bank who's told me that they had done this kind of study with the bank's data. The result? 80% of the bank's data could go on the public cloud. This is a bank in Europe. So my experience here is that people should not let this be a showstopper. They got to pay attention. But in general, if you look at this, I bet you will find that you have more choices than you think you do, more options than you think. All right, I want to talk about scenarios. I want to talk about concrete examples of how enterprises use public cloud platforms and why. To do that, though, I have to give you the world's shortest Windows Azure tutorial. Sorry, Microsoft Azure tutorial. I'll never get that right. So, if you know all this stuff, please bear with me. Honestly, there are 3 slides. So, here we go. For compute, Azure supports IaaS, VMs on demand, where you can have the images, the VHDs, supplied by you or supplied by Microsoft. Either one, great. And there are 2 options for PaaS, the Managed Platform as a Service. There's one called Cloud Services, which was the original Azure technology, and there's a newer one called Websites. They both provide PaaS, managed platforms, in somewhat different ways. Okay? Great. That's all I need to know. For storage, there's blobs. Blob is an acronym for binary large object. Blobs are like a big sand in the sky, bunch of big chunks of binary data. You can also, of course, run various DBMSs, SQL Server, Oracle, MySQL, whatever, in IaaS VMs if you choose to. And I got to stop right here for a second because look what my slide says. My slide says SQL Server, unsurprising, it's a Microsoft technology, but MySQL. You know, Microsoft talks a lot about open source on Azure. They run Linux on Azure. Whoa. If you, like me, have been here a while, you know that Microsoft has often talked about supporting other non-Microsoft technologies. They've often talked about this. Have they actually done it in a serious way? Often not, right? So, with open source, are they serious on Azure? My personal opinion, yes, they're serious. And here's why. 2 reasons. Number 1, they are serious because if they don't do open source and do it well, they have no chance of success in this market. Their main competitors, Amazon and Google, both are very open source oriented. They support that strongly. Microsoft has to do this or they will not survive. Second, you got to realize, what is Azure selling? It's selling compute cycles, VMs by the hour, and storage. Who cares what software burns those cycles, uses that storage? You don't care. This is not the software business. This is the cloud platform business. From their point of view, if you spend all your money on Azure running Linux and MySQL, they don't care. The charge is much the same. So, for good, sound business reasons, that is to say, they'll make more money, Microsoft supporting open source, I think, is a serious thing. One more storage option. There's this thing called SQL Database. It was called SQL Azure. It's a managed PaaS-like approach to relational storage. There are actually other options. This is not an exhaustive discussion at all. My goal, though, is to introduce the core technologies that underlie the most important enterprise scenarios today for public cloud platforms. And there's only one more of those. It's this. You enterprises all have data centers. Public cloud platforms like Azure have data centers. You can create, with a thing called Azure Virtual Network, a VPN between those two. So you're able to have machines, VMs, in Azure data centers appear to be on your own network. What you do here is you actually take the IP addresses from your own space on premises, put them in the cloud. So it looks like these things are on your own network with this VPN connection. So there you have it, the world's shortest Azure tutorial. You need know very little technology to understand the core scenarios that enterprises primarily move forward with initially on public cloud platforms like Azure. There's one more thing you have to know, though, and I'm sure many of you know this already, so please bear with me. The basics of pricing. On Azure, your bill is probably going to be dominated by 3 things: compute, storage, and bandwidth. Compute, of course, you pay per VM per hour. I showed the price ranges there. The prices vary based on the size of the VM and its capacity. Okay? Great. For storage, the price varies based on how much you store. The more you store, the less it is per gigabyte per month. And on storage complexity, you pay more for SQL database, relational processing and storage, than for simple blobs, unsurprisingly. And finally, for bandwidth, bytes transferred into Azure data centers are free. There's no charge for inbound bandwidth. Microsoft is happy to have you give them data they can then charge you to store. They're good with that, okay? When you move data out of Azure data centers, however, they charge you. And the charge varies depending on how much you send. The more you send, the cheaper it is, and where you are in the world. US and Europe have lower bandwidth costs than Asia Pacific. So, in most cases, those 3 things are what dominate pricing. Since a lot of the arguments for using public cloud platforms are rooted in price, not all, but a lot of them, having a basic sense of price is important to understand this. And one more thing. Most of you in the room who are enterprises probably have enterprise agreements with Microsoft. Those all come with discounts. So these are the rack rate prices. Those of you with EAs, probably most enterprises in the room, will not see these. You'll see lower costs than this. So with all of this as preamble, to make sure we're all on the same page, let's start walking through some scenarios. And I have divided the scenarios into two big groups because how are enterprise IT organizations organized? In most cases, there's one group with one leader doing infrastructure and one group, another leader doing app dev, custom app dev. So those two sets of scenarios are, in my experience, quite disjoint. Different folks care about different things. I'm going to talk about them separately. I'm going to start with infrastructure. I feel just a little overdressed. So can I take off my jacket here? Is that all right? OK, great. Example scenarios. Here's what I see enterprises adopt. Data storage. People start with some kind of storage and or they start with VMs on demand, principally for dev test scenarios. You heard that this morning in the Amazon presentation, if you were here. Disaster recovery is one you see more and more. You see deployment of packaged apps like SharePoint. You see, finally, the last step in this process, typically, moving existing apps to the public cloud. This order is not random. This order reflects something fairly close to the most common sequence that I see. So one way to start is to use cloud storage, principally blobs. For example, Microsoft sells this device called Store Simple. I'll say a bit more about it on the next slide. In essence, what it does is acts like an on-premises SAN that silently behind the scenes moves data back and forth to blobs as required. That's one way to use blob storage. You can also do backups to blobs. Various Microsoft technologies in System Center, SQL Server, Windows Server have built-in support for doing blob-based backup. Third-party software also talks to blobs. And of course, any applications you might build might use blobs to store data, video, whatever you like. The most common scenario right now for adopting Azure storage in enterprises is the leftmost one in that diagram. It's Store Simple. It's worth a little bit more conversation here. Store Simple looks like this. It's a device. It sits in your data center. It's a box. It looks like a SAN, but it's got relatively small disk, relatively, compared to a big SAN. Because what it's doing is, in the background, it's moving data back and forth to Azure Blob Storage. In the process, it dedupes, it compresses, it encrypts the data, and puts it in blobs. On demand, as you need it, it will pull it back. If it's not used often, it pushes it out. The Store Simple device acts like a cache. Great. You can see here, data is encrypted, and the key stays with you, not with Microsoft. This is a big reason why people start here, because the trust issue is so large. Having the key stay with you is a way to build that trust, to start that process. So that's what the scenario looks like. Why does anybody want to do this? The overwhelming reason, in my experience, why enterprises adopt this scenario is to save money on storage. Here's a concrete example. Suppose that you want to store a terabyte of data in geo-redundant blobs. What is a geo-redundant blob? It's an option where when you put your data in an Azure data center, that data is replicated behind the scenes automatically, silently, to another data center in the same region, e.g. in the US or in Europe or in Asia. Why do that? Disaster recovery. In the event of a total data center failure on Microsoft's part, your data is still copied over here. It's an option. It costs you money. I chose to use it here because I want to be clear. I am showing you the most expensive storage option for blobs. This is as pricey as it gets. It goes down from here. So a terabyte of data in these geo-redundant blobs. Suppose you're doing 10 million reads and writes operations a month on the data. There's a really small charge for reads and writes. You'll see it's tiny. And suppose you move out 0.5 terabyte a month. what will your cost look like for storage? Well, there's storage, there's operations, there's bandwidth. It varies in the US and Europe. The total cost for your terabyte per month looks like this. $121.50 a month in the US, a little bit more in Europe. I'm sorry, outside US and Europe, in Asia Pacific. And by the way, I see folks taking pictures of my slides, which I appreciate. I like your enthusiasm, thank you. I'm happy to send you a PDF of the deck as well, so not an issue. Okay, so I ask you, $121.50 a month for a terabyte of data that is replicated across 2 data sets. Compared to your on-premises SAN, is that expensive or is that cheap? I know the answer, actually, right? It's dirt cheap. It's just dirt cheap. And this is why people adopt this strategy. It's because doing this is just a cheap way to get more storage, and everybody wants more storage. So this is one of the most common entry points I see to using public cloud platforms. It's storage with, in particular, Store Simple. The other really common entry point to cloud platforms for enterprises is VMs on demand, principally for dev test. The scenario looks like this. An IT admin or a developer uses Microsoft Azure virtual machines to create IaaS VMs. Ordinary old VMs running Windows or Linux, and development teams can then use those for their dev test. And by the way, Windows or Linux. I promised I would tell you why Microsoft changed the name of Windows Azure to Microsoft Azure. They changed the name because of their focus on Linux and open source. It is not just a Windows platform. That's why they changed the name. It's interesting. This is not your father's Microsoft. So that's a simple environment. If you want to get more complex, you can. You can do things like this. You can create the VPN connection between your data center and an Azure data center. You can also run Active Directory in both places. You can run Active Directory in a VM on Azure. Some of you might know. There's a technology as well called Windows Azure Active Directory, which is wholly different from this one. It can connect to this, it's just different. This is vanilla, ordinary Windows Server AD. You can make the Azure Data Center part of your domain, part of your forest, if you choose to, for single sign-on and so on. Now I can have my VMs, and my developers and so on can use them. Why does anybody do this? Well, once again, it's because it lets you get these low-cost VMs quickly and easily. You ask for a VM, it's there in 5 minutes, approximately. You can use them for development, use them for a variety of things. You can also do this not just for dev test scenarios, but for proof of concept, for other kinds of innovative new things. And it's really cheap to have it available. The VPN connection costs 5 cents an hour if you choose to do it. So, storage and dev test are the 2 big entry points that I've seen most enterprises start with in adopting Windows Azure as a public cloud platform. Why? To build trust and to deal with regulatory concerns. In dev test, you're probably not using real data, so you're probably not constrained too much by regulatory issues. You can start here, build trust, get going. Once organizations have built some trust, they next do things like this, in my experience. They next say, well, what if I start using Azure for high availability or disaster recovery? You can, for example, have a backup SQL server on Azure and set this up with something called an always-on availability group, such that an on-premises failure will cause your application to fail over to the cloud-based version of SQL Server. That's an HA scenario, I would argue, high availability, more than true disaster recovery. Microsoft announced just this month, availability just this month, something called Azure Site Recovery, which allows a broader DR scenario by letting you do Hyper-V replicas to Azure, which is interesting. Why would you do this? Because it is so much cheaper to use IaaS for disaster recovery, where you spin up the VMs when you need them, than it is to have a whole separate data center sitting empty and waiting for disaster. Disaster recovery is such an obvious scenario for IaaS. It makes so much sense. I'd be stunned if 5 years from now, people are still doing DR with standalone data centers. IaaS is just such an obviously better scenario for this, at least financially. There are cases where it's not going to work, but in general, it's a much better approach if it does work. And if you want global recovery, there are data centers around the world. So, by the way, I should tell you, doing this talk as a live session for audiences, it's an hour and a half. They gave me 45 minutes. So if I'm talking kind of fast, this is why. Right? I've cut some things out, but nonetheless, I want to get through these core scenarios. After building some trust, enterprises also, in my experience, start doing things like this. They deploy packages, like SharePoint. They build their next SharePoint farm on Azure. Why not? The users don't care. They can't tell the difference. Once you have enough trust in the system and have handled regulatory concerns, why not do this? Well, maybe that's the wrong question. The right question is, why do this? Why would you do this? Here's why. A compelling reason why is faster deployment. You don't need to wait for central IT. You know, if you're a business unit and you say, central IT, I would like a new SharePoint farm, what will they say to you? In many organizations, they will say, sure, you got it, no problem. We'll get it up in 6 to 9 months. And the business guys say, no, no, no. This gives them VMs in 5 minutes. They can start today. They can go around central IT. And I know what some of you are thinking. Some of you are thinking, David, I am central IT. Right? I don't want them going around me. Sorry. Even if your CIO is a graduate of the Joseph Stalin School of IT Management, you will not be able to stop the business from doing this. Give it up. Don't even try, because you will lose. A much better strategy is to be the guy who helps guide them toward your, let's say, corporate chosen solution, rather than just go wild by themselves. Being a concierge is much better than trying to block it, because it will not work. It will not work. You might also do this because it lets IT become OpEx, not CapEx. There are some CFOs who love this idea. There are some CFOs who hate this idea. Depends on your organization. And finally, lower cost. Azure is probably cheaper today than your on-prem data center. Probably. Whether it is or not, I promise you it will be cheaper 5 years from now. I promise you. And here's why. There are 3 massive organizations, Microsoft, Amazon, and Google, all of which are providing public cloud platforms at massive scale. What are they selling? Well, most fundamentally, they're selling VMs running Windows and Linux, IaaS. They're selling blobs. Well, gee, exactly how much differentiation is there in VMs and blobs? Answer, not much. What they're selling is pretty close to commodities, yes? Like wheat, like airplane seats. And they're selling these commoditized services at enormous scale with the requirement of massive capital investment. What happens in markets like this? Answer, prices go to costs. We're seeing massive price drops, and I'm telling you people, we ain't seen nothing yet. In just a short time, no other data center, well, maybe the NSA, but except for the NSA, nobody else is going to have the scale required to compete price-wise with these guys. Certainly not your data center. And honestly, I gotta say, my personal opinion, I am mystified about how any other cloud provider thinks they can compete against Microsoft, Amazon, and Google in terms of pricing, just because of the massive scale we're talking about here. So, if Azure is not cheaper than the data center is today, maybe it is, maybe it isn't. 2 years, 3 years, 5 years, no CFO is going to let you not use these things, because they're going to be so much cheaper than what you have. Finally, once people get real trust, real faith, real confidence in public clouds, in my experience, they start doing this. They start saying, you know what? Let's just move our apps. Create some VMs, set up an environment where it looks like it's on-prem, great, and start moving our apps. Super. Why do you do this? I just told you. The overriding reason is cost. And focusing on what you do, which is not running data centers. Find me a CEO of a non-technology company who loves writing checks for data centers. They don't exist. They don't. So why would you do this? Lower cost. Here's a simple example. Suppose I'm going to move a small application. It runs in 2 medium-sized VMs. It has a relatively small database. You can see there with a few operations, data transfer, okay, great. The pricing looks like this in US and Europe. Running that app costs $280.10 a month. I asked you earlier about storage. I said, was the price I showed you expensive? Was it cheap? The answer is we know. People all know their storage costs, in my experience. Here, when I ask groups of IT leaders if that's expensive or cheap, the honest answer, overwhelmingly, is we have no idea. Matt Wood, the Amazon guy this morning, told us about a large company that simply could not figure out their on-prem costs. Yeah. However, if you are serious about adopting public cloud platforms, and if you're not, you should be, what you have to start doing now is understanding your current costs. Because the public cloud platforms I showed you earlier, like Azure, have these very crisp and clear pricing models. You know what it's going to cost. To know whether it's cheaper than what you're doing today requires having a pretty good sense of your own costs. And you know what? If you ask your own IT guys for these costs, be aware, they will lie to you. Right? They've got an incentive to lie. So, you know, that's a little too strong. If you're an IT guy, that was just a joke. But still, you know what I mean, right? There's incentives here that don't work all in the same direction. Okay? All right. You know, forgive me, conference sponsors. I'm puzzled. How long do I have? Do I have until 2 o'clock? Or until 1:45? 1:50. I have till 1:50. OK, great. I have 12 and a half minutes. Whew. All right. Our last section here, new applications. Again, infrastructure is one place organizations often start. New apps is another. There's lots of ways to categorize new apps. Here's the buckets I want to use. Apps that are used by employees, they're internally facing. Apps that are used by customers, they're externally facing. And in their own category, parallel applications. Okay? 3 big buckets for apps. For new apps used by your employees, you might choose to build that app on IaaS, such as Windows Azure Virtual Machines. Great. The app's running on IaaS. It's used by your own people. Why would you do this? Why would you do this? Well, again, it's faster. You don't need to wait for your IT guys to create the infrastructure you need and do all this stuff. It's just right there in 5 minutes. Great. It's faster. You also might get some capabilities you can't otherwise get very easily, like geographic distribution or up and down scaling. You can shut VMs down when they're not in use and save money. And finally, again, cost. Maybe today, certainly tomorrow, for some value of tomorrow, this is going to be cheaper than your on-prem data center. Okay? Notice what's not in this list. People do not do this for scale. I find that cloud platform vendors so often emphasize the glories of scale. And that's important sometimes, but not for enterprise applications. Enterprises don't need scale. Compared to consumer apps on the internet, employee-facing apps have very small scale. So I don't typically see enterprises choose a platform like Azure for scale for internally facing apps. Now, you might also choose to build those apps not on IaaS, but on PaaS, Platform as a Service. As I told you earlier, Azure has 2 PaaS platforms, one called Cloud Services and a newer one called Websites. Great. There's a session on websites here tomorrow. It's interesting technology. Why would you do this? Why use PaaS rather than IaaS? Well, in general, PaaS platforms are a managed environment. You need not create the platform. It's there for you. You just give it your app and it runs your app. And the platform then manages it as well. So it's lower cost over time because you have less management to do. The first speaker this morning, Stephen Martin, pointed out that he's never met anybody who likes patching servers. Well, these guys patch servers for you, and so on. And since PaaS gives you fewer things to configure and manage, you have fewer things to screw up, so they're lower risk. Faster, cheaper, lower risk. PaaS is a slam dunk, right? Why doesn't everybody build all their new apps all the time on PaaS? Well, in my experience, the biggest answer is that lots of developers are very accustomed to the classic world of a VM, of IaaS. With PaaS, you give up some control, and some number of devs just don't like this. I think of IaaS, not PaaS, IaaS, where you have to manage the VM yourself, but you have total control, as embodying the Peter Parker principle from Spider-Man. With great power comes great responsibility. That's IaaS. PaaS, managed environment, a little less control, but faster, cheaper, lower risk. Your choice. For customer-facing apps, you might build those on IaaS or PaaS. I'm showing PaaS here. Why would you do this? Because for customer-facing apps, big public consumer apps, you really do care about scale. If you're building a consumer-facing app and you're not building on a public cloud platform, you ought to reconsider your architecture. Because these guys are just designed for this kind of massive scale. Heck, Microsoft has said clearly that its initial goal for Azure was supporting Microsoft's own public cloud SaaS applications. And they build their new stuff on this. So if it scales for them, it'll probably scale enough for what you're doing. Scale is a compelling reason to use public cloud platforms for public consumer-facing applications. There's a bunch more as well. You can scale up and down easily. You can replicate for reliability. There are built-in services like NoSQL databases and so on. Other reasons here why you might do this. Again, the cost issue always appears, and the issue of faster deployment, especially with PaaS. So if building an app facing your customers can be more scalable, it can be faster to get up and running, and can be cheaper, well, you got to get past those trust issues and those regulatory issues. But once you've done that, it's a pretty clear decision that public cloud platforms are a good choice. Finally, the last category, parallel applications. Here, what you're trying to do is use lots of, in this case, virtual machines at the same time to get work done. And there are two big, broad categories of parallel apps. The first one is sometimes called big compute, but it's more often called HPC, high performance computing. And the idea there is that you want to get a bunch of machines, in this case virtual machines, up, run your app across those machines, get the results back. You run the app in parallel to get lots of CPU time in relatively short wall clock time. What do you use this for? The paradigmatic example is simulations of bond portfolio performance, of car crash, of whatever. Some kinds of applications fit very well into this model. They're called embarrassingly parallel. They're so easy to make parallel. Here in HPC, what you want is massive parallel compute. The alternative, the other category of parallel apps, is commonly called big data. It's architecturally similar. You're running things in lots of VMs at one time. But now you're not trying to get lots of CPU power. Instead, you're trying to get lots of disk access. You're trying to get lots of disk access to read lots of relatively simple data, usually, and do quite simple things on it most of the time. The parallelization is about disk access, not CPU. In this world, there is a single technology that has come to rule. It's Hadoop. You are free to build your own Hadoop cluster on Azure IaaS if you want to. If you feel you should do this, you have a severe problem with masochism, because it's just pain. There are instead services like HD Insight built into Azure, which will construct these clusters for you. So why do people build parallel applications on public cloud platforms like Windows Azure? Again, lower cost. This is so important. Today, If you're a mid-sized company or a small company and you want to do some kind of very cool HPC simulation or some kind of big data processing, option number one is to go buy your own physical cluster. And for most of history, computing history, that was your only choice. You had to buy a bunch of computers, deploy them, manage them, pay for them, keep them busy. It was cost prohibitive for all but the largest firms. Here, in the brave new world of public cloud platforms, oh man, you can just spin up VMs when you need them, do your simulation or your work for 5 hours, 10 hours, 20 hours, shut them down, stop paying. Public cloud platforms democratize access to parallel applications. This is a huge thing for especially small to mid-sized companies. They also make it easier to manage these things. Microsoft has technologies that automatically will build and manage HPC clusters on Azure, and HD Insight builds and manages a Hadoop cluster. So the barrier to entry in terms of technical skill goes way down, since the software and the service does more for you. So I've walked through 3 big categories here of applications for public cloud platforms. New employee-facing apps, new apps that face your customers, new parallel apps. There are lots of ways to categorize this. I find that breakdown most useful. Okay? So we're done. Public cloud platforms can provide, I believe, better infrastructure services, lower cost, more reliability, better support for new apps in many cases. My experience in giving this talk to lots and lots of organizations around the world is this. It is that at least one of these scenarios has value for every enterprise right now. Let me ask the room. Who thinks at least one of these has value for your organization right now? At least one of these. Right, I see basically all the hands I saw earlier for enterprise IT people. I am not surprised. My last thought, my final suggestion, my final question to all of you is this. What are you waiting for? Thank you very much.